I've been recently doing work to write a replacement for an old astronomy library I've been maintaining for a number of years, and so I thought it would be an opportunity, since I was going back through the process of writing an API from the ground up, to share with you things I've been reminded of and things I've learned through that experience. So the goal today is I'm just going to reflect upon the practice, specifically of Python API design, through my recent work on the Skyfield astronomy library, currently on GitHub, but I'm planning to release the first version to the Python package index during the sprints this week. The whole idea of being able to get your own device at home and predict where one of the planets is has for many people been of perennial interest, going all the way back to practical astronomy with your pocket calculator, and then the later update, which taught you how to do it in BASIC back in the 70s and 80s. This inspired a lot of hobbyists who were amazed that they could predict things happening millions of miles away from their home machine. One such person was named Elwood Charles Downey. He's a professional astronomer who works on radio telescopes, and he came up with two different programs that he shared the source code to on the early internet, EFIM in 1990 and XEFIM in 1993. The names came from an ephemeris, which is the old Latin term for a table of predictions about where something will be on a given night in the night sky. EFIM was an old curses-based terminal program that you could enter the date and where you were observing from, and it would tell you where to look for the stars and the planets. And then XEFIM took advantage of the new X Windows system, graphical window system for Unix machines, and actually could draw a picture of the night sky, as well as letting you solve equations and do analysis, and drive a professional telescope from it. Because this was his work, doing telescope guidance, he always had a license where he reserved the right to distribute binaries, but he did allow hobbyists to download the source for private use. It's a bit hard to get compiled these days, but the procedure is always, if you download and compile something and it can't find a c.h file, just on your Ubuntu box, do an apt file search for that path and install the package that it comes back with. If it's missing a library, if it says I can't find the library XEXT, search for libxext.a, and after about 5 or 6 installs, you'll have X Windows up and running on your, even though it uses Motif, this ancient library that probably didn't come installed on your Ubuntu box. But instead of using GUIs, I like to write scripts. It's more scalable to have a script rather than having to set up the GUI to March 1st and running 30 positions, and then setting it up at March 1st again if I need to adjust it. And I noted that inside of that source code I could download is a computational engine called libastro, sitting in a different directory than all of the Motif GUI code. He'd refactored it fairly cleanly, and I did a little experiment and found that I could pull that out and put it behind a Python interface and script all of the calculations that you normally had to do by moving sliders and pressing buttons. When I showed it to him, he said, "You have my full permission to go with what you have and to release it online," even though it used part of this commercial offering that he makes his living with. That was very generous of him, and it resulted in the publication and availability for 15 years now of PyEFIM, written initially entirely in C code as a wrapper around libastro. When I first did it in '98, I used David Beasley's. Anyone used Swig before? The simple wrapper interface generator. It just was about the only alternative I had at the time, and it just basically sets things up where you can malloc memory and poke information into C structures manually, which meant that your Python code looked about as pretty as your C code. So in 2003, I replaced the Swig-generated interface with a handwritten one that used Python 2.2's exciting new superpowers they had just invented descriptors and had this beautiful ability at the C level, when you're defining a Python type, to just list all of the attributes along with C language getters and setters, and it took care of the object interface and let you just deal with the behavior. It was really pretty and made it fun to write. And like many libraries had done in the standard library, I used that opportunity to also go ahead and put a pure Python wrapper on top of the C, like several standard library modules do. So I now had a more Pythonic edition of PyEfim. You could instantiate the Mars object, ask it to compute its location, and then print out its coordinates in the night sky. Far more convenient than dealing with C structures. But both interfaces were still based on C code and still required compilation. There was a bright past where all computers came with compilers, but in the dark future, that is no longer the case. So because most computers don't come with compilers these days, in the early 2000s, I got to enjoy emails with titles like PyEfim 132 build errors. Win32, does FIFIM work there too? And trying to download, but I can't unzip it. Because, of course, it's a tar file. But the package really started to gain momentum in the late 2000s. It couldn't build on Mac PPC. People couldn't build it on Snow Leopards. It got installation errors on OpenSUSE, Ubuntu, and Windows 7. It was now a software project that couldn't compile on a dozen different platforms. The Mac situation was sorted out by some generous contributors that I would give them ideas and they'd try it out until we got a Mac version working, and someone's now put it on Mac ports, so it's now very easy for the dozen people who still use Mac ports to install. On Windows, I learned about bdist, setup.py bdist wininst, which actually makes this Windows installer for your package. I used a free MinGW compiler at first, and then I finally broke down when I found that they do give Visual Studio away for free as Visual Studio Express. It's closed source, but I mean, it's Windows. So I installed it and was able to get Windows versions of the installer up and running for people. So even though I now have it pretty much working well on most platforms, C extensions are still difficult to install, to distribute, because you have to pre-compile them for most people, and to maintain. So I slowly grew up into the idea of an alternative approach. But I never wanted to pull the trigger because it would just be rewriting what I already had in Python. Then one day I got an email. I'm interested in ephemeris options for astrology apps. A lot of your email, if you do an astronomy package, is people that are very disappointed with modern astrology and want to try re-implementing like the actual stuff from 16th century books to see how those computations worked. You probably know about the Swiss ephemeris, which I'd never heard of. Do you know how it compares in accuracy? So I went and looked up the Swiss ephemeris. Well, first I looked, how does it compare in accuracy? I looked inside of libastro, and it uses a fairly good algorithm called VSOP87 for predicting where the planets would be. Someone contributed this later after the first version had come out, and Elwood incorporated it. Then I went and looked at the Swiss ephemeris, and it was a bit fancier. It's a commercial offering for the use of astrologers, and it said it is based on the DE406, the JPL long ephemeris from 1997. And so I went to the JPL FTP site, and I discovered that that was not the most recent JPL ephemeris. There were a number of more recent ones sitting in the JPL FTP directory. In particular, I started reading about DE421. That was even more recent than the Swiss ephemeris, more accurate. Oh, and I love the technical description of it. Talked about how you use it to achieve planetary navigation accuracies. That's because like the JPL lands probes on other worlds using this data. And there's not a lot of support that they have time to offer the outside world, because these ephemerides, these plurals of ephemeris, are for internal consumption. One part of the JPL produces these, and then the people flying probes places use them. So it's neat to see the little internal conversation as the numbers guys coach the probes guys on how not to crash things. And then I said, wait, what? The technical report said that the ephemeris uses the International Celestial Reference Frame, which, like the Swiss ephemeris, I'd never heard of, but since this was in a JPL report, I figured I'd better look it up. This led me to a great document because of all of the changes that have recently happened. A great guy at the Naval Observatory just wrote up a whole circular introducing computational astronomers to the new world. He introduces it by saying, the resolutions passed by the International Astronomical Union at its General Assemblies in '97 and 2000 are the most significant set of international agreements in positional astronomy in several decades, and arguably since the Paris Conference of 1896. That sounds so cool. The Paris Conference of 1896. I remember it well. No, I mean, doesn't that just sound so fancy? So I didn't know what this is, but I knew I wanted a piece of the action. And so it turns out it was time for a rewrite. Since the technologies were put together that appeared in Peter Duffett's 1970s and 80s books and the technologies used in LibAstro in the 90s, astronomers had discovered a number of underlying systematic errors in all of their data sets. And around 2000, they basically started over again with an entirely new position and coordinate system that all new work, including recent JPL ephemerides, have been based on. And so now I was open for a rewrite that wouldn't just be a boring re-implementation in Python of what already existed in C, but it would be something new. Writing in Python a complete replacement of the old algorithms used throughout PyEfem, so that what came out would now be much, much higher quality and much higher precision. I wanted to replace the entire API with something that reflected what I'd learned over 15 years. I wanted better integration with the new scientific Python tools like IPython Notebook. I wanted to let you give me a whole vector of dates and come out with a vector of positions for Mars or whatever. And I wanted to, this time, avoid reinventing several wheels that are already offered in SciPy. For example, computing sunrise. You ask the sun where it is at 6 a.m., 5 a.m., 5:30, until you narrow in to the moment where it happens to be right at the horizon, sunrise. I had, in PyEfem, to write my own early 2000s handwritten implementation. But now, I think I'll offer users an IPython notebook showing how to use the Newton's optimization already built into SciPy to do this. Instead of having to give people cock and bull, Brandon has made them up versions of fundamental things like finding an intersection of two curves, I can point people at some of the best scientific tools available and get amateurs starting to use real scientific Pythonic tools. And I'm calling this new library Skyfield. So I want to talk about what it's been like writing it over these last few months. And so first, what tools am I using these days? Well, briefly, Git for version control, Jedi installed in my editor so that when I type the name of a Python object and hit dot, it comes up with all of the possible completions. When I put parenthesis, it brings up the doc string of the function or method I'm calling so that I remember how to call it. Py.test for running my tests, and then talks to when I'm ready for an important commit, making sure that my py.test tests run on Python 2 and Python 3. I always tell py.test about my restructured text Sphinx documentation, so the documentation is always verified to work against the current code. Py.test lets me use normal assert statements where I use normal inequality and equality symbols to make the tests look like normal code. I distribute my tests. If you install Skyfield, the Skyfield test module gets installed too. I see no reason, why to try to save a few bytes on your hard drive, but deprive you the ability to run the same tests I do to see if it works on your platform. And I also even just go ahead and throw in the documentation, not the compiled HTML, but at least the source restructured text every time it's installed, so that everyone who installs it gets the same package of information I'm developing from. Licensing is an interesting question. Should I use a restrictive license like the GPL or one like the MIT? The dream of the GPL, which in the 90s I always tended to release things under the GPL, was that the free world that opens their source code is competing with the closed world, which is going to crush us like a bug because of the amount of cache it has. And so we need to deny them use of our libraries so that instead of just rushing ahead to awesome like we do, they're slowed up and have to use some of that enormous pile of cache by finding an alternative or doing a rewrite. The idea of people that use the MIT or BSD license is a bit different. It's just to let anyone use the library for commercial, non-commercial, open or closed projects so that your library gets used both in the free world and the closed world. And something people have started to notice is that if you look at this second diagram carefully, in this version of the world, open source is everywhere, instead of only being in one of the two columns. Open source can become ubiquitous if companies aren't afraid of a legal entanglement by using it. It's Python's own model, and Python, as you heard this morning, is increasingly everywhere. And I decided to go with MIT and BSD because it looks to me, as I look at the projects that are succeeding, it's almost like it's the free kind of freedom that's what wins. And I think at the moment, I'm interested in the kind of world where open source is everywhere, where everyone agrees that an open source OS and web server is what you build on whatever kind of work you're doing, because I think it's more powerful to be everywhere and in everything than to cordon ourselves for the moment off into a different world. So that's what I'm doing with Skyfield. So, what is my development technique? I'm maintaining a single code base and constantly testing it to make sure it runs on both Python 2 and 3, using all the kinds of tricks that were covered in the talk a few minutes ago upstairs. Great talk. Go look at the slides if you didn't see it. Very, very practical detail. I went ahead, and when I found small features that were kind of separate from the rest of the library, starting at PyCon Canada last November and December, I went ahead and test launched a few projects. I would get a feature like doing XYZ coordinates from a JPL ephemeris. I would package that up with tests, with documentation, and go ahead and release it on PyPy. And people have already gone ahead and started using these smaller libraries and emailing me. And it's much more comfortable, I find, to release small projects rather than write and write and write for a whole year without any public projects out there yet to show for it. And as I've been developing, I've been carefully monitoring my own emotions. I have increasingly come to believe that emotions do a good deal of work in telling me whether I'm programming right. Do I, at the moment, feel frustration? If I stop and touch my jaw, are my teeth clenched? Do I feel trapped in the current task I'm doing, and do I feel really miserable? Remember the old saying that your attitude will get built into your work. There's an old belief that the attitude you have as you do handwork becomes a part of what you're working on, and I think that might apply to my code. So if I'm feeling those feelings, it's a signal that I might be doing my programming wrong. Frustration often signals that I haven't set up the project structure so that I can succeed, or so that I'm likely to succeed. One thing I've noticed is that tiny goals are easier to reach and keep me calm than, big, huge, I'm going to go all the way to the end and implement the whole API in a single step. Since I discovered this and started to notice over the last year or two that little goals quickly make me happy and make me less afraid and less anxious, I thought, maybe I will write a blog post about this. And I searched for, testing and anxiety. It turns out the very first book on test-driven development opened with the sentence, "Test-driven development is a way of managing fear during programming." It's a great idea, so I'm not ashamed of having rediscovered it by accident years later. But little tests, writing a little test piece of code, either over in the docs or in a formal test, and then seeing if I can get it working, is a way to make a large project be built of smaller pieces that are easier to manage. I always use version control, and I have come to really realize that it's really, really easy for me to have to throw code away. Like, if I start writing code and I start getting this sense that I'm tangled up and that everything I'm doing is breaking something else, it's often far better to just throw away what I've done, start back at the last change point, and move forward, to the point that my attitude has really come to be, how soon can I commit so that I can't lose what I've just typed? Because especially on something like astronomical computations, I probably threw away 2/3 of the code I wrote because it was so rare at some points for me to start writing code and not break everything hopelessly. When I was young, I thought about refactoring and making subroutines as about the question, how can I split this big task into small pieces for the computer's sake? Now that I'm old, I realize the question is really, how can I split this task into small pieces for me so that I can manage them? A big slog, a huge hour-long march towards a new feature risks everything, and often I wind up having to throw the code away. It's little, easily achievable goals that I usually get to keep. Find a rock climbing friend and ask them how far above their rope they're willing to climb. I always, when it is time to throw it away, some people type git checkout master and it blows everything away they've just been working on. I use git stash, which puts in a temporary record all of the changes you did just have on the table so that you can go look at that diff as kind of a guide to your next attempt to get that working. And so I'll, again, aim for kind of a moonshot. I will say, all right, next I want the library to do this, and I'll try to write the simplest possible code to get me there, ignoring for the moment special cases, and try to just get it working. Because then I can check in, and then I can go back and write a test for all of the little special cases and other features I want to do along the way. So as I've been doing this, I've had to look straight in the face of the mistakes I made when writing PyEFM. What are some of the sins of my older APIs? First, inscrutable names. You heard me talk about this if you were at PyCon back in March. I did a talk on naming. But briefly, who, looking at this first piece of code, would guess that you are getting the astrometric right ascension and declination off of the Mars object? I don't know what your answer is. From my email box, I can tell you that it wasn't obvious to a lot of users. And so Skyfield is actually going to spell out, yes, it's typing, but your code will actually say astrometric if that's the set of coordinates you're asking for, because then you have some hope of knowing what's going on when you read the code. Another problem, as in that code you just saw, is note that in the old way I was doing it, the object itself had its current coordinate. The compute method would write back onto two of the object's attributes what its position is, which is kind of an anti-pattern in Python. because it means if I have a number of dates that I want to have the coordinates for, I have to do a dot compute, and then before I do the next dot compute, because it's going to overwrite those two attributes, I have to save them away. And so you have to do a loop that keeps saving the attributes before they're overwritten. And as you can see, my new library, because it doesn't write the attributes onto the Mars object, but pulls them off in a new position object, you can easily, if you have 100 dates, pull out 100 positions and look at their coordinates. Does this look familiar, by the way? This is the pattern that Python got built in when we moved from using sort, which requires you to build the list, stop and sort it, which doesn't have a return value, and then put together the results. And it's the same thing that was done in the standard library when we added the sorted, when Raymond Hettinger put in the sorted built-in, when we now could get a source of data and run it through a number of transformations without ever having to stop. I'm trying to build that kind of thinking into the Skyfield API. Making code more functional like this is a big part today of making it more Pythonic. Another sin I committed was concealing the expensive operations. Your API, if you think about it, is the only lifeline the programmer has to managing complexity and expense and knowing where in your API the mines, the expensive operations lie. Looking up in PyEthim the name of an object, or doing an expensive computation, or doing the dozen expensive computations to compute the rise time all looked the same. So I'll offer you a guideline. It's okay to hide quick conveniences behind properties, but I think expensive operations should always look like calls with parentheses. Use this difference to train your customers by making some things look cheap and expensive things look expensive. A Python programmer who has any experience will look at this and think, oh, .name, I can just use this over and over again and it won't cost anything. But when they see those parentheses, they'll know it's expensive and they'll think about things like saving that to a local name if they need to use it a dozen times. What's the big lesson that all of these observations moved me towards? I have come to believe that we should write APIs that teach. You know how your API works and how it can best be used, but your API needs to teach people about how it should best be used. Share as much of your knowledge about the problem domain as possible. Write APIs that teach. While an API should, the whole point is to hide complexity, it should also by its structure suggest best practices. One tiny example of how an API can teach is the requests library. Who here has ever used it? It's a great way to do HTTP. The old standard library call is URL open. I think that's a bad name. Requests has you do .get. What's the difference? They accomplish the same thing. Well, when you say requests.get URL, your very first line ever of requests code teaches users their first HTTP verb, get, without their ever knowing it. Someone really new to the web and just trying out Python probably doesn't know HTTP is a protocol. Yes, even despite the P at the end. They probably don't know it has verbs. But on the day they finally do learn that, they'll realize that all along Kenneth Wrights was teaching them that basic verb's name, and they'll probably even on that day suddenly guess that requests has a .post. Because in that name, Kenneth is surfacing information about the hidden protocol beneath the library. PyEthim made every coordinate an attribute, looking exactly the same, all a flat attribute on the object with no apparent relationship. So Skyfield, instead of hiding all of the steps of doing a computation, has you spell them out as a series of cascading method calls so that it will be more obvious what the difference is between an astrometric and an apparent, for example, coordinate, because you'll see that extra steps are intervening before you can get the answer. This will help give me a structure for answering a lot of the common questions that wind up in my email box. Another sin is confusing functions and methods. Now, this is easy to do because Python does support both procedural and object-based methodologies, but choosing can be a bit difficult. Here are some guidelines that have kind of helped me recently. This is a kind of error I made where I had a constellation function, and you had to pass it in the right order, the correct two numbers from another object. Why wasn't it a method on a coordinate object, since that's the only kind of thing you can possibly pass this function and have a sensible answer come out? So here are some guidelines. First, keep in mind that methods constitute Python's one built-in type check. If you've ever accidentally tried to call a method on the wrong kind of object, it actually breaks. It's the one clean way to limit the types that a function accepts without having to do something ugly and manual on your own. If you're ever tempted to start a function with if is instance and checking its argument, then that might mean that you want to write a method instead. F of x should, by definition, if it's a function, touch only public features of an x and not reach inside to do magic. If f of x needs internal details, either make it a method itself or create a method, or you've discovered a problem with your object interface and need to provide a way into that information. F of x, if it is a function, should by definition not mutate the state of x. X, in most cases, should come back from a function call undamaged. If you need to mutate state, look at something called the adapter pattern, where you wrap one object in another, because an experienced programmer is more used to a wrapper changing the file that they're looking at than a function. This hurt a lot in PyEFIM. Asking a location to figure out the next rising above the horizon rising of an object changed the object, because it kept asking it, where are you at 6 a.m.? Oh, where are you at 5 a.m. until it found the moment of rising. Users never expected to go back to their Mars object later and find that its location had changed merely because they asked a Toronto object when it was next going to rise. And fourth, remember that methods are discoverable. If someone's using an editor hooked up to Jedi and hit tab, they'll see a list of the methods. It's a lot harder for them to go looking and find the functions that might run correctly on the Mars object. A few new tricks I've used with Skyfield very briefly. What about when you need to dynamically compute an attribute, where you don't want to pre-compute it, but for semantic reasons it should really look like an attribute? Doing a property is a problem. Notice that .upper is going to run every time you ask for the .loud of this object. The problem there is hidden expense. So a lot of programmers cache the result after they compute it the first time, using maybe a non-public attribute like this. And that way you only incur the expense of .upper the first time they ask for the loud version of a message. The problem is that this makes every access a little more expensive, because it at least is going to involve a function call and the if statement. And often I'm now in astronomy writing classes where you're going to need one of those coordinates a dozen times. And so I actually have gone back to 1990s, Brandon, and have written one or two getAttr methods. Because the beauty of getAttr is it's only called if the initial lookup of the attribute fails. So while it's slightly more expensive when they first try to use a given attribute, it then is zero expense and no code even runs on every subsequent access. That's been working very well for me. For a value frequently accessed in heavy work, it only runs on the first lookup. Another trick has been learning how to write scalar code that actually will run on arrays. You can do this with NumPy. You can write a function that not only looks like, but as you can see, will indeed take normal numbers as its input. And because of the magic of NumPy arrays, you can also pass arrays in and get an array result out without even rewriting the function. This looked really incredible to me, and I thought, I'll do that everywhere in my astronomy library, where you can Either pass in a single date and ask where a planet is, or pass in a whole range of dates and get out a whole series of coordinates across the sky. It was a great idea, but it turns out that scalar style is hard to maintain across a large code base when you're, for instance, translating coordinates into a different coordinate system and having to do big matrix operations. You can't really be agnostic about whether it's an array or whether it's a scalar. So I'm winding up with a lower level that's all arrays, and then up at the top level, if I see the user gives me a number, I turn it into an array, but then give them answers that are numbers back. And one last hint, when doing anything mathematical about the sky, remember, pi is old-fashioned, pi is out of date, pi is an unnatural number. Weihart will remind you that tau is the true constant. The circumference of a circle is 2 pi. Oh, there was also the question of, should my dunder init import things? A lot of people do this at the top level of their library so that users can just import from the name of a library the things they need. The pro argument for this is that it's a simple way to surface your primary interface, but it does have some cons. An import Skyfield will wind up importing everything because it recursively grabs the things inside of it. And it also means that imports won't match error messages, which can be confusing for certain users. I decided against it. Skyfield has a lot of things in it, and you might only want one of them. It helps users learn the package structure in case they want to look in and see how it works. And I can always later write a Skyfield.api module that, by importing it, imports all of the high-level bits for people to use. They can make that decision to import the whole thing at once. I have not been afraid to go with opinionated defaults, so it comes with an ephemeris by default, even though that's somewhat big. I'll skip the bit on contrived tests because I want to talk about support. Support forums are often quite terrible. I hate looking up a problem, finding a mailing list post that exactly describes the problem I'm facing, and finding that it's 4 years old and that the solution doesn't work anymore for the current version of whatever library it is. An answer can also be difficult to find within a long discussion thread. Which of the 7 people that answered an old email post actually knew what they were doing, if any? Answers go out of date, and so I actually am using Stack Overflow as the official PyEFM and Skyfield support forum. Answers are on the same page as a question, and out-of-date answers get fixed. Even if I'm long gone from that question, if people are returning to it and it no longer works, someone will go in and give the correct answer. So I want to close in my last minute or two here by talking about what I call the last mile. Any old telecom people in the room who remember what the last mile refers to? It's the name in telecom for the most painful part of the entire telecom system, the actual little wires that go from the central office to your house, the ones that break because tree limbs fall on them and things like that. It's the most difficult thing to support because there's millions of last mile loops, and every one of them is susceptible to a limb. And so I have 2 thoughts about the last mile of an API, the actual delivery to your users. Lesson number 1, a new GitHub issue appeared for PyEFM. Somebody was saying that it was broken. And it said PyEFM works on my internet provider from SSH, but it doesn't work from the web. So they had installed it at the command line, and they hit reload on the web app they were writing, and PyEFM wasn't there. Obviously a problem with the way their internet provider has set Python up. I was unhappy. This meant that there was another open issue on my beautiful project. Remember, an issue is a way of kicking somebody online. It's a way of telling them you are wrong. And this person, I was not wrong. Their internet provider hadn't set up Python correctly. It was like an Amazon review where they say, this is a terrible book. It never arrived. I can't believe it. This is terrible service. Creating a GitHub issue because you can't install packages on your ISP is like reviewing a book with whether or not you happen to have received it from the seller. The very last phrase after the description of the problem was, "Can you help me?" And I thought about the fact that things rarely go well when I make a decision while my feelings are busy feeling. So I came back to the issue later that evening, and I remembered a month earlier when I had asked a question on a particular forum only to be told, this question is not a good fit to our Q&A format. I won't mention the provider. Can you help me? A GitHub issue is not where to get support for your ISP's Python installation, but can you help me? And I decided that the answer was yes. He couldn't do any logging the way they had set Python up on Apache. He couldn't add any print statements. The web app wouldn't load because of an import problem. So I showed him how to hide something up at the top of his code before it hit the import statement and died that would give him an emergency message about what his sys.path was set to. We figured out the sys.path when he ran Python and PyEfim successfully from the command line. And I said, okay, go to the top of your script, import sys, and sys.path.append the location of where we've just figured out PyEfim is, and it worked. He then talked to his ISP, and they said, oh yes, the official support solution is to keep that emergency code in every script. Very good, Brandon was right. They had no idea how to support Python. But because I just decided to keep that issue open for 3 days, it only took me probably about 15 or 20 minutes in all answering his questions. The result is that his Brazilian web astronomy club now has the positions of the planets in the upper left-hand corner computed with PyEfim every time you hit reload. His last message was, Brandon, thanks a lot for your help. PyEfim is great. And my initial reaction was going to be to close the ticket, because darned if my nice software deserves an open ticket because of a Brazilian ISP. Thanks a lot for your help. PyEfim is great. Lesson 2. In October, I found a library that I wanted to compare my own results against, Novus by the Naval Observatory. They just had it on their website, and so I went and it's a public domain because the US government wrote it, so I put it on the Python package index, and then I got an email. Someone said, I've been fiddling around with Novus Pi and have had some problems, and listed some bugs in the Naval Observatory Python code. And the temptation, of course, was to say, oh, I'm sorry, that's not my library. I didn't write it. That's not my problem. I even thought I would be a hero and provide the email address of the Naval Observatory. Maybe even I would forward his problem to them myself. And so I was all ready to send this person off to an email address I actually know doesn't answer a lot, when I looked at the bottom of the message, and it said, Assistant Director for Exploration at nasa.gov. Can I help him with the Naval Observatory's observational code? And it turns out that when NASA needs help using a library written by the US Naval Observatory, it's the guy who put it on the Python package index who goes in and fixes the bugs and gets the guy at NASA right back up and running and then sends them back upstream. Yes, I am America's liaison between billion-dollar government agencies. And a lot of it comes down to, guys and girls, it comes down to the last mile. Your work, your beautiful API, your stunning internals, your great design decisions don't mean anything if someone who's in a tight spot, they've spent hours and nothing works, simply gets told that they've asked the wrong question to the wrong person. everything is for nothing if they don't get that last mile, that bit of completely out of context help that gets them working. The last mile in open source, the final component of your API is very often you. Because when all else has failed, you are the API of last resort. Thank you very much. I'm told that I've run a bit over time, so I'll walk down here and take questions from the front. Thank you very much.